is Alexa Roberts, and here is my Lab 1 constant velocity for Physics 1 at Georgia Tech. For our table of contents, we have our introduction, physics principles and formulas, experiment, analysis of glow script and tracker, our discussion, then we'll close it off with conclusions. The purpose of the lab was to compare the observed position of an expo marker that is moving at constant velocity, which means no changing directions and no net force, to the predicted position found from using a coding computational model called glow script. Physics principles that were used include Newton's first law, which says that an object will stay in motion unless acted on by external forces, and in our case, the system moves with constant velocity, so there are no net interactions. And Newton's second law, which is our momentum principle, pertains to net interactions between system and surroundings, which is net force, and how it relates to changes in momentum of the system. So looking at our formula, we have delta momentum over delta time. Additional physics formulas that were used include position update formula, which measures two positions and allows us to determine the average velocity for object during time interval. And for constant forces, we use V average in this formula, and for non-constant forces, we use V final. Then for the velocity update formula, this just predicts the velocity at some time later. And if the net force acting on a system is 0, then the velocity will not change, therefore representing constant velocity. Our experiment system was the expo marker, as you can see in the image, and that's just what we're focusing on, and the surroundings are anything that's interacting with the system, so the foot in this case kicking the marker and air resistance. And then our experimental position was calculated using tracker, and then predicted was using glow script. Our procedure included recording the expo marker rolling after being kicked at constant speed, inserting the video into tracker, and using this data as well as a starter code to determine the predicted position using glow script, which is our computational model. And then we compiled this data into Excel to compare our results. For our initial conditions in glow script, we can see that the net force is equal to 0, and then we have our velocity update formula and position update formula. Then we have the expo marker's mass, and then we have the time it took from the start of the kicking of the marker to the end of the kicking, which was it stopping. For our initial conditions in tracker, here are two graphs that kind of represent the relationships that were going on, and then the total time it took from the marker being kicked to the marker stopping was 8.33 seconds, and then our initial position was calculated using tracker, and then we have the formula for where we found our initial velocity. For our glow script and tracker combined data, we can see that our results for glow script and tracker are pretty similar, and they do deviate a bit, but we're going to go over some potential sources of error. And then also our data represents that there was a constant velocity, so there was no acceleration, and the net force was equal to 0. So for potential sources of error, we have air resistance as well as human error. And human error could have been done when we were trying to calculate the original position of the marker and tracker, and this could have been when we were editing the video. So our discussion, what if and what does it mean? What if the axes were flipped? Then the slope of the graph would be negative and there would be opposite signs, but the net force would still equal 0. And how many pushes and pulls, which are forces, are being added together to give 0 net force? We are unable to tell how many forces are being added together due to the normal force and then the force due to gravity canceling out. So overall, we would just know that the net interactions and net force equals 0, and then there could still be forces happening, but they cancel out. For our conclusion, we know that Newton's second law was supported due to the little deviation in our Excel graph between the observed and predicted position when comparing over a time interval, which showed constant velocity and no net force.